In this video lesson, we are going to look at 2D trigonometry. And as usual, just before we get started, I just want to remind you on how to do mathematics. Now, make sure that you understand each step in the examples. Then you will not learn how to do math by reading it or watching someone else explain it to you. Understanding the steps does not mean you can do it on your own yet. Therefore, to get the most out of this lesson, make sure to pause and do the questions before watching the answers. And then you improve your skills only through practice, but more specifically marking your practice sums and learning from your mistakes. Okay, now this video consists of 5 sections. First, we're going to look at the sine rule, then the cosine rule, then the area rule, then the numerical problems, and then finally general problems. Okay, now the sine rule is as follows. It says that side A over sine A, so if you have a triangle with sides A, B, and C, then side A over the angle A, sine of the angle A, will be equal to side B over the angle of sine of B, and then equal to C, side C over sine of angle C. Okay, let's see how to apply this. Now, first of all, use the triangle below to prove the sine rule. So first we're just going to prove it. And this is a question that you can find in an exam. They can ask you to prove the sine rule, cosine rule, or the area rule. Now, for all three, the start is basically the same. The first thing you do when you have to prove any one of the three is you construct a line down perpendicular to the line CB. All right. And the reason I believe is that once you've constructed a line that's perpendicular, you've got two right angle triangles, and with a right angle triangle, because the triangle in which you're going to apply the sine, cosine rule, area rule is 90% of the time not a right angle triangle, because you can apply it in any triangle. So now we've created two right angle triangles. Okay, so then for the sine rule, now this line, we're just going to call it H. You can actually call it anything. We'll just call it the height. Okay, so with the sine rule, since we are proving the sine rule, we are going to use the sine ratio. And we are going to be focusing on this angle and this angle. So first of all, I'm going to start by finding the sine of angle C. So sine C is equal to opposite over hypotenuse, so that's H over B. And then do the same for the other triangle and find sine of angle B, and that's opposite over hypotenuse, so that's going to be H over C. Okay, now I've got these two relationships, and we can see that H is common in both of them. So what I'm going to do is I'm going to solve for H. I'm going to say H, and we're going to use cross multiplication, so I'm just going to multiply this B up with sine C. So this is going to be H is equal to B sine angle C, and do the same here. H is equal to C sine angle B. Right, now if H is equal to this and H is equal to this, then it means these two are equal to each other. So B sine C is equal to C sine B. Okay, and we're almost there. Now we can just rearrange a bit. And once again, we can use like the cross multiplication method, and we can take sine C downstairs and take sine B down there. So this is going to be B over sine angle B equals to C over sine of angle C. Okay. Then we can say similarly, we can show that A over sine A is also equal to B over sine B, which is equal to C over sine C. And then we've basically proved it. Okay, now to apply it. In this example, it says calculate B. Now, in this example, we are calculating this side, B, and when you have this question in an exam, they are not going to tell you, okay, now use the sine rule, like we have it here. So how to identify this, just remember, just look out for a side and its opposite angle, and a side and its opposite angle. Once you have that, like side, opposite angle, then you can use the sine rule. Okay. Even if you can, maybe they can give you this R, then, and not P or not Q, but then you can just use angles of a triangle to solve for the one you want. Okay, so what we're going to do is our relationship we're going to use in terms of P and Q. So the side P over sine of angle P is equal to side Q over sine of angle Q. Right, not theta Q. Okay. And then we can replace the values, or substitute in the values. Now P is what I want to solve. Over sine angle of P is 57 equals to Q 4,9 over sine 69. All right. And then we are going to use cross multiplication to isolate P. So P is equal to 4,9 sine 57 degrees over sine 69. And all that's left now is just to substitute it into the calculator. Okay, so this is then, normally we round off to 2 decimal places, so it'd be 4,40, but since it ends with a 0, I'm just going to write 4,4. Okay, now calculate x. So here we can see we've got the side over the angle, side over the angle. So x over sine of x is equal to y over sine of angle y. Substitute in the values. X over sine of 40 degrees is equal to 10 over sine of 70 degrees. Solve for x, take the sine 40 up, that's 10 sine 40 over sine 70 degrees, and type it into the calculator. Okay, so that's 6,84. And that's in centimeters, so we're just going to write centimeters. Okay, then calculate x again. But now, in this case, we actually don't have the opposite angle. But we do have the other two angles of a triangle, which means we can just quickly solve for that angle x. Because we know if we add up all the angles of a triangle, that should give us 180. So that's equal to 180, and angles of a triangle. So this is going to be x equals to 180 minus 65 minus 37. So that gives us 78. Okay, so that is 78 degrees. So we can go ahead and we can say x over sine x equals to z over sine z, big Z, and then substitute in the values. X over sine of 78 degrees is equal to 6 over sine of 65 degrees. So solve for x, then it's 6 sine 78 over sine 65 degrees. Okay, and we substitute that into our calculator. 6 sine 78 over sine 65. Okay, so that's going to be 6,48 centimeters. Right, now in this example, example 35, find the value of angle P. Now in the previous examples we found the sides. Now we need to find the angle. Now we know the formula goes like this, where we have P over sine of angle P equals to Q over sine of angle Q. But when we want to solve for an angle, it's easier to write it in this form, where we have sine of angle P over P equals to sine of angle Q over Q. And we can do that because we can manipulate this form, like we can take that up, bring that down, take that up, bring that down. So we are allowed to write our formula in this way. And I would highly recommend it when you want to solve for an angle. It's just easier to solve that way. Okay, now substituting in the values, we've got sine angle P over P, which is 4, equals to sine Q. Oh, I wrote theta again. Q sine 48 over Q is 5. Okay, solving for sine P is then just take the 4 up. So 4 sine 48 degrees over 5. And then finally, to get rid of the sine, I take the inverse of sine. So angle P is the inverse of sine of 4 sine 48 over 5. And I would recommend you don't like simplify this yet, just to keep your answer as accurate as possible. And just write the whole thing like that. Okay, and then we substitute in, so shift sign, that's important, shift sign, then 4 sine 48 over 5, and that gives us 36,48. Okay, and now we have calculated an angle, so we're just going to say degrees. Right, so for this question, calculate theta. Okay, so we're going to say sine of theta over y is equal to, so we have these, sine of z, angle z over z, and substitute in our values. Sine theta over y is 7 equals to sine z is 72 over 8. Solve for sine theta, we get 7 sine 72 over 8. Then take the inverse there, so theta is equal to sine the inverse of 7 sine 72 degrees over 8, and then we substitute that in. Shift sine 7 sine 72 over 8. Okay, and that gives us 56,32 degrees. Okay, so the last question for the sine rule, we need to solve for theta. And we have our angle and opposite side, angle and opposite side. So we have sine theta over z equals to sine x over x. And then substitute in sine theta over 9 is equal to sine 38 degrees over 8. Solve for sine theta. So take the 9 up, 9 sine 38 over 8. And then take the inverse. So sine inverse 9 sine 38 over 8. And then type it in. Shift sine 9 sine 38 over 8. Okay, that gives me 43,84 degrees. So that was the sine rule. Next we're going to look at the cosine rule. So the cosine rule is as follows. When we have any triangle, either one of these three relationships hold. So we have a squared equals to b squared plus c squared minus 2bc cos a. So if you start with the side a squared, then the angle is going to be the opposite angle in the relationship or the formula. Alright, and then it can apply to any of the three sides. Alright, so we can also have b squared equals to a squared plus c squared minus 2ac cos b. And one way to recognize the cosine rule or to identify it is when you're given a question and you see that what is given would be two sides and you're given the angle between the two sides. If you see that, immediately try and or think about the cosine rule, because most of the time when you're given two sides with an angle in between the two sides, then the cosine rule might be applicable. Okay, now here we're going to look at proving the cosine rule. So first of all, we know we're going to construct a line, and I'm going to call this point, and this line is perpendicular, so I'm going to call this point D. Alright, and then we just need to set up our triangle with a few more variables. We can call this distance here, we can call that x, and if this distance is x, then this distance CD will be the entire distance a, and then you subtract x from it. So this is going to be a minus x, okay, because we're basically just interested in CD. And then we can call the perpendicular height h. Alright, now I'm going to just give you a preview on what we're going to do, and then I'm going to do it. So in this case we are going to use Pythagoras, and we're going to first find the Pythagoras of this side C, and then we're going to find Pythagoras of side B. Then we're going to substitute the one into the other, and then since we are focused on the cosine rule, we are going to find cos of B and also then substitute into the original formula. Okay, so first of all, let's find Pythagoras of side C. So C squared is going to be h squared plus x squared. Okay, and we can just state that this is Pythagoras. And then we're going to find Pythagoras of side B. So b squared is equal to h squared plus x, or a minus x. So a minus x squared. And again, we have used Pythagoras. Alright, now what we can do is we can further expand this, and I'm going to just multiply this bracket out the faster way. Just be careful not to make the common mistake of just taking the x squared to the a and the x and then leaving it as that. Remember, these are two brackets next to each other. So this is h squared, and then the fast way to expand this is to say a squared, multiply the two together, multiply by 2, so minus 2ax, and then plus x squared. Alright, now if we look closer, we can see this is h squared plus x squared, and here we also have h squared plus x squared. So what I'm going to do is I'm going to reshuffle this, these terms, and then I'm going to substitute in for c squared. So I'm going to start with a squared plus h squared plus x squared minus 2ax. Okay, then this part over here I can replace with c squared. So this is a squared plus c squared minus 2ax. Okay, now what we're going to do is we're going to find the cos of angle B. So cos B, and this is just the ratio of cos B, is adjacent over hypotenuse. So it's going to be x over c. And then we're just going to solve for x because we want to substitute that into this formula to get everything in terms of a, b, and c. So to solve for x, we can use cross multiplication. If this is over 1, we just multiply the c up. Then we'll have c cos b equal to x. Okay, and now we can just replace that x with x's value. And that would give us b squared equal to a squared plus c squared minus 2a, and then the value for x is c cos b. All right, angle b. All right, we can also continue and say that similarly, we have a squared equals to b squared plus c squared minus 2bc cos a, and also c squared is a squared plus b squared cos c. All right, and then we've done our proof. Okay, now applying the cosine rule, we are first going to look at what's given and what is asked. So in example 36, we are asked to calculate b, so this side b, and we are given the side c and side a, and also this angle 63 degrees. All right, and as you can see, we've got two sides with its included angle, and if you don't know which section you're working, well, obviously in the exams you won't be knowing what's, now we are working with cosine rule, so it's obvious, but if you don't know, then this is a good indication that you need to use the cosine rule if you have two sides and an included angle. Okay, so we want b, so I'm going to say the formula I'm going to use is going to be the one that says b squared equals to, and then the other two, a squared plus c squared minus 2ac cos of b. Right. Now, what we're going to do is, I'm just going to first solve for b, because this is b squared. We don't want b squared, we actually just want b. All right. So let's take the square root of that. And the reason I'm doing it now is it's very easy to forget to take the square root at the end after you've actually substituted and solved for it. So let's just get that over and done with and do that immediately. Okay, so now let's substitute in the values. So a is 5, c is 6, minus 2, a is 5, c is 6, cos of b is 63. Right, and then we just type it in to the calculator. We have the square root, so it's 5 squared plus 6 squared minus 2 cos of 63. Okay, that gives us 5,81, rounded off to 2 decimal places. Okay, so we're not given any units, so we're just going to leave it like that. All right, now after you've done this, hopefully, calculate a, then we are going to use the formula a squared is b squared plus c squared minus 2bc cos a. All right, so let's just solve for a. That's the square root of b squared plus c squared minus 2bc cos of a, and substitute in the values. B is 15, c is 10, and then 2, again 15 and 10, cos of a, that's 15. Okay, let's type that onto the calculator. Okay, then we get 5,93. And this is in centimeters, so we're going to write centimeters because we're working with this distance. Right, then question 36.2, calculate C. Now, side C over here. So once again, we have C squared equals to B squared. Well, actually, that should be A, but it doesn't really strictly matter. It doesn't really matter. But let's just do it alphabetically. Plus B squared minus 2AB cos of C. Okay. C is the square root of A squared plus B squared minus 2AB cos of C. And then we substitute. A is 5, B is 10, cos of C, 67. Right, so to 2 decimal places I get 9,27. And this is meters. Let me just double check. Yeah. Alright, now for the next type of question. In example 37, it says find the angle of G. So in this case, we are given three known sides, but we need to find the angle. So actually notice something, that if you have all three sides of any triangle, you can find the angle by using the cosine. So you can find any angle actually by just using the cosine rule. Okay, but for this question we need to find angle G, which then means we are going to use a formula where as the first variable is going to be, remember when the first variable is G squared, the angle that's applicable is the big G. So we want to have G squared is equal to H squared plus I squared minus 2HI cos of G, angle G. Okay, now this one, there's a choice. Okay, you can solve first, like, because we want to get to this angle, all right? We can solve for that first in terms of the other variables and then substitute in, or you can do all your substitutions of your known variables and then solve. Now, for me personally, I just think it's easier to first solve because sometimes you have really big numbers and then you have to kind of throw them around. So I just think it's easier to solve first and then substitute. So that's the way I'm going to go. But you do what your teacher prefers probably, or what you prefer. So yes, so let's start. So first of all, the G is the one I want to solve for. So, and we've got this term, and this term. So remember that's separate terms. And so I'm going to, for two reasons, I'm going to take this term over this way. First of all, because it contains the unknown that I want to end up with. And the other thing is it's a negative on this side. So just throwing it over that side makes it positive, which immediately clears that out. So this side and all of this must move together because it's one term, they stuck together. So this is going to be 2HI cos of G. Okay, and then this G squared I'm going to bring to the other side. Okay, so this is then H squared plus I squared minus G squared. Okay, now we want to get rid of this coefficient. These 2HI is just the coefficient of cos G. So we can get rid of that next by dividing both sides with it. So this is going to leave us with cos G equal to H squared plus I squared minus G squared divided by 2HI. Okay, so far so good. And then we just have the G that we need to isolate. And to do that, to get rid of this cos, we're going to take the inverse of cos. So this is then G is equal to the inverse of cos of h squared plus I squared minus g squared all over 2hi. Okay, right, so now we can just substitute the known values. Okay, so we'll have 6 squared plus I is 4 minus g is 5 all over 2. H is 6 and I is 4. And then type it into the calculator. And that gives us 55,77 degrees. Alright, now just for the sake of those that prefer to substitute it in first, I will do this example by substituting in first and then solving. Now we want to find angle I. So the formula we're going to use is I squared is equal to, so we've got h and g, h squared plus g squared minus 2hg cos of I, angle I. Alright, let's substitute. I is 5, so 5 squared equals to, then h is 10 plus g is 8 minus 2, so h is 10, g is 8 cos of I. Right, and then we solve. So once again, I'm going to take all of this over to the other side. Also another option is to simplify this so long if you want to. So we can just change this into 80 times 2, which is 160. So this is 160, and now it's positive 160 because this whole term was negative, which we brought to the other side, which became positive, cos I, okay, equal to, and then we've got this, yeah, you can also, but let's just do it like that, 10 squared plus 8 squared minus 5 squared all over, oh, not yet, okay, we just brought this term to that side and that term over to that side. Okay, now we can divide both sides by the 160. So we've got cos I is equal to 10 squared plus 8 squared minus 5 squared all over 160. Okay, and one final step, we just take the inverse. So I'm not going to simplify this yet, because when you get decimal places, you don't want to round it off yet before you get your final answer. So that's why I'm just going to leave that as it is. So I is the inverse of cos of 10 squared plus 8 squared minus 5 squared all over 160. Okay, so starting with the inverse of cos, then fractions, then 10 squared plus 8 squared minus 5 squared all over 160. Okay, so that's 29,69 degrees. Okay, then for the final question, we have not, they've not given us a sketch. They've just stated in triangle ABC, A is 27, B is 35, and C is 46. Find the size of B. So we can just do a little pencil sketch just to give us like basic layout of what it looks like. So remember, the triangle can basically look like anything. We just know the longest side is C, which is 46. Okay, which means the opposite angle there would be C. And then we have the second longest one, which is 35, preferably more straighter than what I did, but that's B, because the opposite angle will be B, and then A is 27, and that would be A. Alright, now we want to find the size of B, which means we're going to use the formula B squared is equal to A squared plus C squared minus 2AC cos of B. Okay, so I'm just going to solve for this first. Take the last term to the other side. 2AC cos of B is equal to A squared plus C squared minus B squared. Then divide both sides with 2AC. So cos of B is equal to A squared plus C squared minus B squared over 2AC. Okay, and then take the inverse of cos. So B is inverse of cos, and all of that stories again. Okay, and substitute. A is 27 squared plus C is 46 squared minus B is 35 squared, all over 2 times by 27 times by 46. Close bracket. Okay, so we have shift cos, and then we have 27 squared plus 46 squared minus 35 squared, all over 2 times 27 times 46. Okay, so that gives us 49,29 degrees. Right, so that was the cosine rule. Next up is the area rule. Alright, now the area rule is for triangles, obviously, the area of triangles. Now we do know the formula, hopefully, for area of triangles is half base times perpendicular height. Now the thing that is a bit of a headache is the perpendicular height, because as we can see in this triangle there is no perpendicular height, or it's not given that two sides are perpendicular. And what makes the area rule quite useful is that you don't actually need a perpendicular height. You can just work with two sides with its included angle. That's important. So you need two sides and its included angle. Then you can find the area of any triangle. Right, whether it's right angled or not, or whether you have a perpendicular height. Now we can apply one of the three formulas. So if you have, for example, A and B, then you're going to use half AB times sine of C, and then the same applies for the other two of the angles. Alright, so let's see how we are going to prove this. Now here we have this triangle, and it says to prove the area rule. And once again we are going to construct this line, and we're going to name this point D again. Now this line is actually the perpendicular height. Alright, so if we had to find the area for this triangle, it would have been straightforward. We just say, okay, the area of triangle ABC is equal to half times base. In this case, we'd have the length A as our base times by the perpendicular height, which is just going to be H over here. Alright, now next up, we are going to have to find H in terms of something else. So we can choose either C or B, and then we're going to apply the sine ratio. And it's easy to remember to apply the sine ratio because the area rule contains the sine. So we're going to say, okay, I'm going to choose B. Okay, so I'm going to say that the sine of B is equal to opposite over hypotenuse, so that is H over C. Okay, now we can actually isolate H and take the value of h and just substitute it into our original formula. Now to do that, we just multiply both sides by c, or we just do cross multiplication, but either way we end up with c sine b, angle b actually, is equal to h, alright? And then I can take this and just plug it in there. So area of triangle ABC is equal to half A, and then H is C sine B. Okay, and we can also say similarly, we have the area of triangle ABC is equal to half AB sine C, and area of triangle ABC is equal to half, and then we haven't used AB, no, BC sine A. Okay, and that's it. So this is quite easy. This is literally just learn it and score some free marks in your exam. Alright, then the area rule applied. So now it says calculate the area of the following triangle. So we have the two sides with its included angle. So first of all, I'm going to start by writing the formula. Area of triangle, again ABC, is equal to half. So the sides I'm going to use is A and C, and then sine of B. And then just substituting it in, half A is 8,5, and then we have C as 7,2, sine of B is 140 degrees, and then it's basically substituting it in. So I'm going to say 0,5 just because it's easier to type in the calculator than 1/2, and then you can choose if you want to substitute it in with the brackets or just say times 8.5 times by 7.2 times by sine of 140. Okay, so that is 19,67. Okay, and then always look out for your units. So it is in centimeters, which means this is going to be centimeters squared because it's the area. Right, then for question 38.1. Now, straightforward, we're just going to start off again writing the formula. Area of triangle GHI is equal to, so we have half, and then the sides we have is G and I, and that is going to be sine times by sine H. Substituting in, half G is 6 and I is 4, sine of 70, and then just typing it. (11,28) meters squared. Okay, for question 38.2, calculate the area of the following triangle. Now, in this case, we do not actually have the included angle, but what we do have is the sides and this angle over here. Now, since the sides are equal, that gives us a way to actually find this angle, because we know that when two sides of a triangle are equal, then the opposite angles will also be equal. So therefore we can first just say, okay, A will also be equal to 25 degrees, and our reason is equal angles opposite equal sides. Okay, and then since this is 25, then obviously we can just use angles of a triangle to find the third angle. So C is equal to 180 minus 25 degrees minus 25 degrees. And our reason is angles of a triangle. Okay, and then C is, this is 50 together, so this is going to be 130 degrees. So this is 130 degrees. Okay, then we can just go ahead and say, okay, the area of triangle ABC is equal to half then AB sine of C, and substitute in sine 130 and type it in. Okay, 0.5 times 5 times 5 times sine 130 is equal to 9,78. 9,58 centimeters squared. Okay, now in this next example, they say that the area of this triangle is 100 meters squared. Calculate h. So here we are actually given the area, but we have to find one of the sides. Now, obviously, the first thing we do is we write down the formula. So area of triangle FGH is equal to half, and the two sides of interest are G and H, and then sine of the angle is F. Okay, now we can substitute. So what do we have? We've got the area, so the area is 100, and then half, then G's value we've got 30, and then H is what we want to find, and sine of 30. Okay, now in this case we need to isolate H. So everything next to it is basically multiplied to it. So to get rid of it, we can just take everything and divide it. So take 100 and divide everything. Think of it as coefficients or products or whatever. So this is going to be 100, and then just divide it with everything else. So half times 30 sine 30 equals to H. So to get H, I'm just going to type that into the calculator. So again, 0.5 times by 30 times by sine of 30 is equal to 40 over 3, but we're just going to also round this off to 2 decimal places, 13,33. Okay, and units is in meters, because this is the side that we found. Okay, question 39.1. Calculate the area of triangle, the area of triangle XYZ is 440 meters squared. Calculate B. So in this case, we actually need to find the angle. Again, area of triangle ABC is equal to, so we have A and C, so half AC sine of B. And then we substitute. So the area is given as 440, then half. A is 20, and C is 45. And then sine and B is what we want to find. Okay, now first of all of this is just the coefficients of sine B. So I'm just going to divide that whole business there. Okay, equals to sine B, and then we can take the inverse. So if we take the inverse, now we can write this the other way around, which would be actually a bit more, but okay, so let's say B on this side is equal to the inverse of sine of 440 over half 2045. Okay, the fact that I've just swapped them around, it's not going to change the values. Like if you have A equals to B, it's the same as B equals to A. So basically what I've done is I've just written everything that's on this side, I wrote on this side, and everything on this side, I just wrote on that side. And then you obviously take the inverse of sine, and then the answer is shift sine 440 over half times 20 times 45 is equal to 77,89, but this is going to change the 9 into a 10, which would change the 8 into a 9. So it's going to be 77,90 to 2 decimal places, strictly speaking. So 77,90, and this was the angle, so it is degrees. Okay, then we are done with the area rule. So next up we have numerical problems. Right, now we are at numerical problems. Now before we get started with the actual sums, I just need to explain something that is actually quite critical to know. Now in numerical problems, there's many real life scenarios that you will encounter, maybe buildings or some ships and lighthouses, but I'm going to use these two buildings just to explain something. So first of all, let's call this guy over here, let's say he's at point A, this one is going to be at point B, and this one is going to be at point C. So let's construct this line, and this line is parallel with the ground, and therefore we can say this is a horizontal plane. So everything that basically falls in this plane is in the same horizontal plane with each other. Okay. Then we can also look at the line of sight between point A and point B, and when we construct that, there's an angle that forms between this horizontal plane and between this line AB, and that angle there is called the angle of elevation. So important to know, because they can just state that the angle of elevation from A to B, so from A to B, that is then specific degrees. So they might not give you, say that this angle is 30. They can only tell you maybe that angle of elevation from A to B will be 30. And then also, likewise, we can construct a line from A to C, and the angle forming between the horizontal line and the angle of that line is called the angle of depression. Right, so these two things are something that you just need to remember and understand. It's not very hard. It's basically just taking the line, and they sometimes you have to, you might have to construct that line, but they'll say the angle of elevation from this point to that point, or the angle of depression from this point to that point. Right, now moving on and looking where we can, okay, so this one obviously is just a normal application, or where we're just going to solve for a side. And before we do that, I just want to highlight something. Now there's two types of triangles. We've got our triangles that are just like maybe a scalene triangle. These do not have contain a right angle. And then we have right angle triangles, which obviously then do contain a right angle. But the point is, which you should already know, is if you are working in these, we are mainly going to use either the sine rule. So you can either use the sine rule or the cosine rule. Okay, and when you are working in triangles which have right angles, you're obviously going to think about the three ratios. So we've got sine theta, cos theta, and tan theta. So depending on which triangle you're working in, immediately think which ratios you're going to use. Okay, so we do know that these are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. All right, and then these, to identify them easier, remember that with a sine, you are using an angle over and a opposite side, and then also angle opposite side. Okay, that's what it looks like. So if you see something like that, angle with its opposite side and another angle with its opposite side, then you're going to use sine. And with cosine, we know that if we see two sides next to each other with an included angle, that's when we want to think about cosine. Okay, but the most popular one is sine. So always try and do sine first. Also because it's much easier than using cosine. Sometimes you might have a choice, but if you do have a choice, go for sine. It's just much easier to calculate. Okay, now let's get started with this question. And it says we need to calculate PQ. So PQ lies here, and PQ is part of this triangle PSQ, which is a right angle triangle. And when we look at our ratios, obviously we're going to use that there. We can see that there's 3 variables, so 3 unknowns, and mostly, or obviously, if you want to find one of them, you're going to need 2 others. So you can have one known angle and one known side, and then you can find the third side, or the unknown side. Or you can have 2 sides, which then allows you to find the angle. Now in this case, when we look at this, we want PQ, so we only have one angle here, which is a problem, so we need PS. Or we need SQ, but PS would be the obvious go-to because PS lies in the other triangle with more information that we can use. So we're going to go and see, okay, let's see if we can find PS. Now, we have this angle over here, which is opposite PS, and we've got this side with an opposite angle, but the opposite angle there is still unknown. So maybe let's see if we can find that angle. Now, knowing these 2 angles, there's 2 ways we can do it. We can either find this angle with angles on a straight line and then use angles of a triangle, but there's a shorter way because we also know the rule that has exterior angle of a triangle. So we know that angle R plus angle P1 adds up to this 68 because it's exterior angle of a triangle. So if I start by that, I can say, okay, P1 plus 40 is equal to 68 degrees, and that is exterior angle of triangle. Okay, and then just solve for P1, take the 40 over it and minus it, so it's 68 minus 40, which is 28. Alright, so that done. Now we can actually see that we have an angle, opposite side, angle, and then just this unknown side which we want to find. Alright, so basically we're going to use sine. And I'm going to start, I always start sine with the one I want. So the one we're solving for is PS. So we're going to say PS over sine, and the opposite angle there is 40, equals to then the side 10 over sine of 28. Okay, now we need to solve for PS, and to do that, to isolate that, we just take the sine 40, we can just take that up. So this is by cross multiplication. So this is going to be PS equals to 10 sine 40 over sine of 28. So we put that on the calculator. Then we have 10 sine 40 over sine 28. So that gives us 13,69. Okay. Now this is over here, and now that we have that, we can just simply say, okay, we want the opposite side, and we have the hypotenuse. So opposite and hypotenuse is sine, so I'm going to say sine, and that angle 68 is equal to opposite, which is PQ, over 13,69. Now isolate PQ, multiply the 13,69 with sine, then we have PQ is equal to 13,69 times by sine of 68, and type that into the calculator. Right, and that's 12,69. Right, and we're not given units, so we'll just leave it as that. So question 40.1 is very similar to the example. Alright, we need to find Px, and to do that I would like to find Pa, and to find Pa we can see that this angle is given with the opposite side. So if we had this one with this opposite side that's also given, we can find PA. So to find that angle, we can just use exterior angle of a triangle. So to find or APB, we can say that angle plus 40,2 would equal to 49,7 degrees, and that's exterior angle of a triangle. All right, and then to solve that, we're just going to subtract. So APB is then equal to, so 49,7 minus 40,2 is equal to 9,5. Okay, now that we have that, this is 9,5. So we have the side opposite angle, so we can use sine rule. So PA over sine of 40,2 is equal to this side 35 over sine of 9,5. Okay, then I'm just going to use cross multiplication. So PA is equal to 35 sine of 40,2 over sine of 9,5, and then just do substitution there, or actually just type it into the calculator. So this is going to be 35 sine of 40.2 over sine of 9.5. 136,88. Okay, and that is in meters. Okay, so we have 136,88 over here, and then opposite and hypotenuse, so that's sine. So sine of 49,7 is equal to opposite, which is px over 136,88, and use cross multiplication, then px is equal to 136,88 times by sine of 49,7, and type that into the calculator. So 136.88 times sine of 49.7 is equal to 104,39. So 104,39, and then that is in meters. Alright, now for the following question, we need to find PQ. So if we look at this, which two triangles will be applicable, because we actually have two right angle triangles, and then we have a bigger triangle which is not a right angle triangle. And it looks like we're going to use the bigger one because we are given this side PR, which belongs to the bigger triangle. And what we need to do is we need to find PQ, which is in this triangle. So if we had, for example, PB, if we had that side, then it would be easy to find PQ with our trig ratios. And to find PB, if I had this angle, then I would have this side over this angle, and we could then have one unknown side over that known angle. So obviously this big triangle, that's easy to find because we can just use angles of a triangle. So B plus 40 degrees plus 66 degrees equals to 180. So we'll have angles of a triangle, right? And then to find B, we just subtract on the other side. So 180 minus 40 minus 66 is equal to 74. So this is 74 degrees. Okay, now using the sine rule, we have PB over sine of PB over sine of 66 is equal to, and then we have, let's see, then we have 20 over sine of 74. Okay, and solving for that's pretty basic. So PB is equal to 20 sine of 66 over sine of 74, and then we type it in. Okay, and that gives us 19,01. So 19,01. All right. So here 19,01, and then to find PQ, we've got from this angle, this is the adjacent side and this is the hypotenuse. So we know adjacent and hypotenuse is cos. So cos of the angle 40 is equal to adjacent over hypotenuse. So this is going to be PQ over 19,01. And solving for PQ, I just take the 19,01 up, and we'll have PQ is equal to 19,01 cos of 40. So 19.01 cos of 40 is equal to 14,56. Right, and that's it. So no units given, so this is basically how we leave our answer. Right, now for the last question of this section, question 40.3. In the figure below, AB represents a lighthouse and then of 112 meters high. The angle of depression, so meaning from the horizontal plane, going down from A to the two boats C and D, so angle of depression, this angle going down and this angle going down to C and D are C and D in the same horizontal plane, so C and D in the same horizontal plane here as B are 74 and 66 respectively. Okay, then we're also given that AX, so this should probably be X over there. AX is parallel to BCD. BCD. Alright, so these two lines are parallel. Now write down the size of angle ACB. So ACB is this angle, and since these two lines are parallel to each other, so we can see that they form a Z, so they are called alternate angles, or we know that alternate angles are equal, so therefore ACB is equal to 74, and we can say alternate angles, whereas AX is perpendicular to B, let's say BCD, or we can just say BC or BD, doesn't really matter. Okay, now for the next question, we are going to calculate AC. So AC is in this triangle. Now, since this is a lighthouse, we can assume that it is perpendicular to the ground, except if it's the Tower of Pisa or something. But this is now the lighthouse, and then since it's in a right angle triangle, we can use the sine rule. So we know that this is 74. Or trig ratios, which is opposite over hypotenuse, which is the sine rule. So this is going to be sine of 74, and that is equal to opposite 112 over the side AC. Okay, now to solve for AC, we can take AC up with cross multiplication and bring the sine of 74 down. So AC is equal to 112 over sine of 74, and then calculate that. And that's 116,51. Okay, and that's in meters. All right, so now we know this side. So the next question says calculate the distance between the two boats. Okay, now this distance, so that's going to be CD, and we are now working in a triangle that is not right angle. So what do we have? We've got this side, which means it would be nice if we had this angle, because that would be an opposite side with an opposite angle pair. And this is the side we want to calculate, so meaning we want to actually find that angle also. Now it's easy to find both of them because we can use again alternate angles. So we can say that D is 66, that is alternate angles, whereas again AX is parallel to, I'm now going to say BD, just to go all the way to this angle, and then to find this small angle over here, we can simply see that this bigger angle, if you subtract the smaller angle, you'll be left with this angle over here, which we are interested in. So that angle is called DAC or CAD. Let's call it CAD. So CAD is then equal to the bigger angle, 74, minus the smaller angle, and that is equal to so that's equal to 8. All right, this is 8. And then it means we have everything we need. So now we can apply the sine rule, and this is what we want. We want CD. So CD over sine of 8 is equal to where are we now? Oh yes, we have this side. So 116,51 over sine of 66. All right, and then I can just use cross multiplication. So CD is equal to 116,51 sine of 8 over sine of 66. And let's just substitute or type that into the calculator. So that's 17,75. Right, and that would be in meters. Right, so now that the numerical problems are done, we are finally now on the final section, so general problems. And basically they look like this. Now, I don't think, or there might be a lot of people that find this really hard. And I think the main reason is it can look a bit daunting sometimes, where you just basically don't know where to start. So there is a way where you can actually like draw a map for yourself to lay out the things you need to do. And it's quite simple because when we're given this, to prove this, it says show that DC is equal to P sine x cos y over sine x plus y. Then most of the cases we are given two sides, and these two sides are actually in two different triangles. All right. So here we have one triangle, and that's where P is, and then we have DC in this triangle. And also with this, it's important to be aware, is the triangle right angled or not, so that you know which formulas to apply. Okay, now the other side that's very important is to find the link between the two triangles. Okay, now this one is quite obvious because the link is simply going to be the line, or the side that's common in both triangles. So we can see that BD is our link. All right, now what we do to draw our map is we want to find DC in terms of the link. Okay, so in terms of the link, and then we want to find the link in terms of P. Okay, now link is BD. So once you've now established, okay, this is the one triangle, that's the other triangle, and also whether the triangle is right angled or not right angled. So let's say this DC is in DCB, and this triangle is right angled, and then also the other triangle where we're going to find the link BD in terms of P, this one is not, so you can just say not right angle. This is just a note to yourself so that you immediately remember, okay, in this one I'm going to use the sine ratios, the trig ratios, and in this one I'm going to use either the cosine rule or the sine rule. All right, so let's start. So first of all, DC in terms of the link. So in that case, we are working in triangle DC, so DCB, let's say DCB. Okay, now we have DC, which is the important side, and BD, which is the link, which is the other important side. And if we want to find an angle, we can see this angle is actually easy to find because it's just 90 degrees minus y, okay, the big angle minus the small one. So this is just 90 minus y. So from this angle, so you normally use an angle that you can easily see, that's easy to find in terms of the other angles. Okay, so from this angle, DC is the opposite side and BD is the hypotenuse side, and opposite over hypotenuse is sine. So if I put that in my trig ratio, sine 90 minus y, it's equal to DC over BD. All right, now let's just go back to the map and see what is it that we need to find. We need to find DC in terms of BD, which means we need to solve for DC, which means I'm going to just take this up. So this is going to be DC is equal to BD sine of 90 minus y. Right, one more thing I can do to simplify this is I can just use reduction formula to simplify 90 minus y, and this is going to be changed into the co-ratio because it's 90. So BD is cos of y. Okay, so revise your reduction formulas if you don't know what's happening there. All right, now that is our first equation. We have DC in terms of the link. Now we need to find BD in terms of P. Okay, so let's see here. Let's first go and try to use the sine rule. And if we're going to do that, BD is the applicable side, and we have the opposite angle, and P is the other applicable side, but we do not have that opposite angle, although we can just use angles of a triangle. So that's just going to be 180 minus x minus y. And simplify that further, just write 180 minus, we're just going to factor out a negative, then we're left with x plus y. All right, so let's do that. I want BD in terms of P, so I'm going to start with BD. So I'm going to say in triangle ADB, we have BD over sine of x is equal to P over sine of 180 minus x plus y. All right. Two things. We want BD in terms of P, so we need to solve for BD. We're going to take the sine x up, and the other thing is we're going to use reduction formula to simplify this. So BD is equal to P sine x over, okay, this is 180 minus the angle is in sine's quadrant, so it remains positive. So this is sine, and it becomes x plus y. Okay, now we have BD, so this is the value for BD, and we have our original formula, or the first formula, whereas we can now just substitute the value for BD into the link there. Okay, so now we have DC is equal to all of that over sine x plus y. Okay, so that's basically substituted in for, brackets not really necessary, but I'm just showing how it's substituted in, cos y. Okay, then let's see if we're on the right track. So yes, there's our sine x cos y, so now we can just rewrite it in the correct formula. Okay, I'm just running out of space here, but DC is equal to P sine x cos y over sine x plus y. Right, and we're done. Okay, so question 41.4. Now let's just first draw our map. We want PQ in terms of the link. So let's actually see what is the link. Let's see, PQ is in this triangle, so we have that, and then F lies in this triangle. Okay, now the link would then be PS, so that's PS, and then we want PS in terms of F. Okay, PQ is in a right angle triangle, and PS is or F is in not right angled. Okay, so let us start with the first one. So in triangle PQS, we want or the applicable sides are PQ and PS. So from Y, it's the opposite side and hypotenuse side. Opposite and hypotenuse is sine. So sine of y is equal to PQ over PS. Okay, and when we look at this again, PS in terms, or PQ in terms of PS, so we're going to solve for PQ. So PQ is just equal to PS sine of y. Right, moving on. In triangle PRS. Okay, so now we're going to use either the sine or cosine. So let's see if we can use the sine rule. Our applicable sides are PS, so we have that angle opposite there, and F, so we need this angle over here. Right, let's look at what we are given here, x and y. Now if we look at this relationship between these three, what we have and what we want, we can see that this forms exterior angle of a triangle, which means that x plus this angle is equal to y. So to find this angle, we can just say it is going to be y minus x. Okay. Now we can apply the sine rule. So I want PS in terms of f, so I'm going to start with PS. So it's going to be PS over the sine of x is equal to f over the sine of y minus x. Alright, now we want PS in terms of f. Solve for PS. So PS is equal to f sine of x over sine of y minus x. Okay, so that's our link, and we can then just put it in there. So PQ is equal to f sine of x and then over sine of y minus x multiplied by sine of y. So I'm just going to put this sine of y. Then we immediately have the correct answer. Okay, now prove that PS is d multiplied by sine x plus y cos theta over sine x. Okay, so our two triangles, let's just locate where is PS. So PS is over here and D is over here. So we need to work our way there, and our link is QS. So I want PS in terms of QS and QS in terms of D. And in this case, PS and PQ is in a, where are we? PS, that's in a right angle triangle. And this one is not right angle. So also remember, in a sketch, they have to indicate that it's right angled. It might look right angled, but if it's not indicated, then you cannot say that it is. Okay, so first of all, we are in triangle QP or PQS, doesn't really matter, PQS. Okay, and then from this angle theta, this side is the hypotenuse because it's opposite the right angle, and this is the adjacent. So adjacent and hypotenuse is cos. So cos of theta is equal to adjacent, which is PS, over hypotenuse, which is QS. So going back to the map, we want PS in terms of QS. So PS is what we're going to solve for. PS is equal to QS cos of theta, right? And then moving on to the other triangle, we have, so let's just write that down, in triangle QSR, okay, we have D and we have QS. So let's see, first of all, sine rule, this pair we have, and then I need this angle, okay. But we have the other two angles of the triangle, which means it's easy. We can just use angles of a triangle, which is 180 minus x minus y. And I'm just going to simplify that again by saying 180 minus x plus y. All right. So using the sine rule, I want QS. So QS over sine of this 180 minus x plus y. Right, and then that is equal to D over sine of x. Okay, now two things. We're going to solve for QS, and we're going to take this up, and as I take it up, I'm going to use the reduction formula, apply that to simplify that. So QS is equal to D, and then this reduces to sine of x plus y. Okay, it stays positive because 180 minus the angle is in sine's quadrant, and then that's over sine of x. Okay, so this I can substitute in there. So PS is equal to d sine x plus y over sine x times by cos theta. So let's see. Yes, so we have that. I'm just going to extend that. Then we have our final answer. All right, last question, 41.3. Now this looks quite complicated, especially if I look at that. But this one wouldn't now solve, or this one wouldn't like exactly follow the same procedure we've done, because in this case we need to find the area. Okay, so actually it is a bit, it can actually be easier, because if we look at the area of KTS, okay, we know to find the area we can just say half two sides with an included angle. So if we write that in terms of what we have already, we can say that the area of triangle KTS is equal to half times by ST times by KT times by sine of the included angle, which is y. So basically we see that our formula here contains an h. Okay, so that's the side there and that side over there as well. So to find this, we're going to find ST in terms of h, and we're going to find KT in terms of h. All right, this one is in a right angle triangle, that one is not. Okay, so let's start with ST. Okay, ST, which is in a right angle triangle, so let's say in triangle STH, we can say the applicable sides are ST and H, and this angle is already given. So from that angle, this is the opposite side and this is the adjacent. So opposite over adjacent is tan. So tan of Z is equal to ST over H. Now we want to solve for ST, so we're just going to take H up. So ST is equal to H tan Z. So basically what we're going to do is, now that we have ST in terms of H, we can just substitute it in there. Right, next step, we're going to look at KT, okay, and KT in terms of H. Now once again, not a right angle triangle, so first go for sine. So these are the angle and side pair, and we need to find this angle and side pair. So we need to find this angle. Very easy, these three lie on a straight line, so we have that, so that's going to be 180 minus 90 minus y. Okay, and simplify that further, that's 90 minus y. Okay, so in triangle KPT, okay, we have what do we want? We want KT, so I'm going to start with KT. KT over sine of x is equal to h over sine of 90 minus y. Okay, so solving for KT and reducing this, KT is equal to h sine of x over, this becomes cos y. Okay, now we just write our formula again, but we substitute the values we got in terms of h. So area of triangle KTS is equal to half, and then we substitute in h tan z, and we substitute in h sine x over cos y, and then we have that sine y. Okay, let's take a peek at the final answer. So we have the half is there, so we can say half, and then h squared, so we have an h there and an h there, so we can multiply those, h squared, then the sine x, so here we have our sine x, okay, then tan z, so there's our tan z, and tan y, so sine y over cos y becomes tan of y. Alright, and finally we are done. And that's the end for this video.